Hello students, welcome back to this session. In today's session we will be covering algebra of functions, and then we will be going to the exercise. Okay, we are going to solve some problems related to the exercise. So a small disclaimer: the images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Now, in today's session, we are going to cover in theory part algebra of real functions, and we will be seeing some related examples. So starting with this example, so examine each of the following relations given below and state in each case given reasons whether it is a function or not. You are given with three relations. In first, you are given with three ordered pairs, 2, 1, 3, 1, 4, 2. In second, you are given with four ordered pairs, 2, 2, 2, 4, 3, 3, 4, 4. And in third, you are given with six ordered pairs, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6 and 6, 7. So as we have already seen a definition for function, that what special type of function relations are said to be a function. Clear? If you try to see here, so for each element in the domain 2, 3, 4, we are having unique images. So simply the first one is a function. While in the second, this element 2 from the domain having two different images. So not a function. And third one is a function. Why? Because every element from the domain has one and only one image. Clear? Moving on to next. Now, starting with this algebra of real functions. Quite simple. So in this, what we are going to do, that we are going to learn how to add two real function, or subtract, or multiply, or clear, or divide one real function by another. We will be going to learn all that. So first one, addition. If you are having two different functions, f from x to r, g also from x to r, any two real functions, I hope that you all recall the definition for real functions. Any function having domain and codomain from set of reals will be your real functions. Clear? Now, then your f plus g, this relation, this function from x to r, defined by f plus g for each input is equals to fx plus gx. So this will be our addition for two different functions, two real functions. Clear? How we are going to do the addition of two real functions. Now, subtraction, quite simple. So if you are having f and g2 function from x to r, both reals, then f minus g, the subtraction is defined from x to r, again x to r, defined by f minus x. F minus g of x is equals to fx minus gx. Clear? Now, for multiplication via scalar, suppose you are having your function f from x to r, a real valued function, and alpha be any scalar. Scalar meaning alpha belongs to some, alpha is your some real number. Clear? Here what we mean by scalar is simply a real number. The product alpha f is a function. So this is going to be a function, and this function is from x to r, and alpha f times alpha f of x is simply alpha times fx. Clear? It will be all clear after you see an example. So just wait for the example. Now for multiplication of two real functions. So product or multiplication are two different terms representing the same thing. So f from x to r and g from x to r, and multiplication is defined in this manner. Your f of g is also going to be x to r function, defined by f g of x is simply fx multiply gx. Clear? This is called your point-wise multiplication. Why point-wise? Because this is your some point, this is your some another point. So point-wise multiplication. Now, quotient of two real functions. If you are having two functions f and g, both real functions defined from x to r, then the quotient function denoted by f by g and defined by f by g of x is simply fx divided by gx. Clear? Obviously we want denominator not equals to 0. So this condition must be fulfilled. Now this example will clarify the things. So if fx is x square and gx is 2x plus 1, so we are having two functions fx and gx defined in this manner. Then find out the sum, the subtraction, the multiplication and the quotient. Quite simple, as we have already seen the definitions. How we defined our sum, subtraction, multiplication of two real functions and the quotient. Now solution. So f plus g simply fx plus gx. So f plus gx will be a function with expression x square plus 2x plus 1. Now f minus g will be your another function. In order to get the expression for f minus g, you have to do what? Simply write fx minus gx. So minus gx will be minus 2x minus 1. And this will be your complete expression for f minus g function. Clear? Now f multiply g, quite simple, fx times gx. So fx is x square, gx is 2x plus 1. The expression will be 2x cube plus x square. Now for quotient, f by g, quite simple, fx by gx. So we are having numerator as x square and denominator as 2x plus 1. But we want some other condition also, what? That denominator cannot be 0. So we have to explicitly write it down. What condition? That x must not equals to minus half. If it is equals to minus half, then my denominator becomes 0. But I do not want that. Clear? Why I am writing this x not equals to minus half. Okay? This example. So suppose fx is root x and gx is your x. And what we want? Quite simple, that find out the addition of both the functions, the subtraction, the multiplication and the quotient. Quite simple. So solution. So what we have, as fx is root x and gx is x. So f plus g will be your what function, in which you have to add fx expression to gx. So root x plus x. Now for f minus g, fx minus gx. So quite simple. The f minus gx will be your what? Root x minus x. For fg, it is fx times gx. So root x times x, which is equals to x raised to power 3 by 2. And for f by g, so f divided by gx. So root x by x, which is equals to x raised to the power minus half. Quite simple. So I hope that everything is clear now. So disclaimer. So the students focus on this problem. Okay. So this question, what it says, that which of the following relations are functions? Just give your reasons. If it is a function, then determine its domain as well as the range. Clear? So you will have some seconds to try this problem. Then afterwards, we will move on to the solution slide. So your time starts now. The time is up. So quite simple question. So the domain for first is going to be this set with element 2, 5, 8, 11, 14, 17, and range will be singleton set. For second, second is also a function with domain 2, 4, 6, 8, 10, 12, 14, and range with range 1, 2, 3, 4, 5, 6, 7. But the third one is not a function. How? So solution. So first one is your function. Why? Because every element, if you try to observe that every element having exactly one image, 2 associated with 1, 5 related with 1, 8 also related with 1, 11 also related with 1, same 14, same 17. Clear? And if you recall the definition of domain, so in order to get the domain set, what you have to collect? You have to collect all the first elements from the ordered pairs which are in the relation. Clear? So collecting all the elements, you will get your set of domain. So clear? So since all elements having unique images, so this relation is a function with the domain set as 2, 5, 8, 11, 14, 17 and range set as 1. Now for second, this relation is given to you in roster form with these 7 ordered pairs. Now if you observe that all these elements of the domain having unique images, so this is also a function. Clear? So domain is quite simple. Just collect all the first elements from the each ordered pair in the given relation, and for a range set, collect all the second position elements from the each ordered pair which belongs to the range set, the relation. Now the third one. So this given relation is not a function. Why? Because if you observe this element 1, it corresponds to 2 different images, 3 and 5. So 1 related to 3 and 1 also related to 5. So not a function. Clear this question? Find the domain and range of the following real functions. So real functions are already given to you. Two real functions, fx is equals to minus mod x and fx is equals to root of 9 minus x square. We have already seen about mod x, modulus function, if you recall. So just give me domain and range. You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. So quite simple. So for first, domain is going to be all real numbers, but the range is going to be what? Non-positive real numbers. Clear? And for second, domain is from closed interval minus 3 to 3 and range is closed interval 0 to 3. How? Quite simple. Fx is equals to minus of mod x. This is your modulus function, mod x, negative of modulus function. We know that mod x can be written in this piecewise form, that for x greater than equals to 0, the output is x, and for any negative real number as my input, the output is minus of that negative number. So the minus of mod x will be quite simple, that minus x when x is greater than equals to 0, and minus of mod x output will be x when x is less than 0. Clear? So since fx is defined for every real number, so the domain is all real numbers, meaning minus infinity to infinity, the open interval. Or you can also write this R, which shows that the domain is the whole set of reals. Clear? It can be easily observed that fx, which is minus of absolute x or mod x, always gives me what? Negative value as well as 0. It can give me 0, but not able to provide me any positive real number. None. So the range is going to be interval open at minus infinity to closed at 0. Now for second part. So fx is equals to root of 9 minus x square. Since root of 9 minus x square is defined for all real numbers that are greater than or equal to 3 and less than or equal to 3. Clear? So what we want is quite simple, that here it must be minus 3. Okay, minus 3. So greater than or equal to minus 3 and less than equal to 3. So the domain is simply what? The set in which you want your x such that x must be greater than equals to minus 3 and less than equals to 3. Clear? Or in interval terms, it will be closed interval minus 3 to 3. Yes? I hope that how we are getting this as our domain is all clear. If you focus on this word, real functions, how we define our real functions, that domain as well as the codomain is from where reals, then you will say that your given function is a real function. Now suppose you are putting any real number less than -3. Just put any real number less than -3, say -4. Then what will be this expression 9 minus x square? This will be 9 minus 16, meaning some negative. And you know that root of some negative number is a complex number, not real. So we are not going to give x less than what? Less than -3. We are not going to provide any real number as my input to this function. Clear? So this is the reason that why I am taking these values, these real numbers as my input. So whenever you have to answer for domain, just look for those values of x you can put. Yes, so you have to search for those values of x, those values of inputs which doesn't contradict anything. Clear? Now, if you are going to put these values, any real number belongs to this closed interval -3 to 3, the output will always going to be lie in between 0 to 3. Clear? Including 0 and 3. So the range set is simply collection of all real numbers x such that x is greater than equals to 0, less than equals to 3. Or in interval terms, closed interval 0 to 3 will be my range set. This question, a function f defined by fx is equals to 2x minus 5. Then you have to write down the following values. What values? That what will be your f of 0, what will be your f of 7, and what will be your f of -3. Quite simple. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple problem. A machine is given to you. If you give your input as x, the output will be your 2x minus 5. Simple. This is your machine. So what you want to know? That what will be your output for 0 input? What will be your output when you give 7 as your input? What will be your output when you give -3 as your input? So quite simple, that for first -5, for second 9, and for third -11. How? Solution. So as given fx defined by 2x minus 5, or this is my machine which takes x as input and gives 2x minus 5 as my output. Therefore, f of 0 is quite simple. The output is twice of 0 minus 5, meaning 0 minus 5 meaning -5. So whenever you give 0 as your input, the output is -5. f of 7, when input is 7, the output is going to be twice of 7 minus 5, meaning 14 minus 5 meaning 9. So if you provide input 7 to your machine, the output will be 9. Now for f of -3, so twice of -3 -5, which is -6 minus 5 gives me -11. Clear? This question, if t, the function t, which maps temperature in degree Celsius into degree Fahrenheit. So you are having your function t which takes input as degree Celsius. So input is degree Celsius temperature, and output is in degree Fahrenheit. Clear? And your function defined by Tc is equals to 9c by 5 plus 32. Meaning, if you have any degree Celsius temperature, just provide to this machine, and this will give you what? This will provide you a number which exhibit what? Which exhibit the temperature in degree Fahrenheit. Clear? I hope what this function represents is clear. Now, we are given with 4 points, and for each point we have to find out. As here in the first, what we are given with? We are given with, if you are having your 0 degree Celsius temperature, then what it will be in degree Fahrenheit. If you are having 28 degree Celsius temperature, then what will be the 28 degree Celsius temperature in degree Fahrenheit. For third, if you are given with minus 10 degree Celsius temperature, then what will be the corresponding degree Fahrenheit temperature. And in fourth, you just have to find out the degree Celsius temperature for which? For the degree Fahrenheit 212. Clear? Quite simple problem. So you have already your machine. Just plug your input, you will get your output. Just plug your output, you will get your input. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple problem. Function is given to you. You just have to find out the outputs for given specific inputs. And in this case, you have to find out input for given output. So for first, answer is 32. For second, 412 by 5. For third, it is 14. And for fourth, the degree Celsius temperature is going to be 100. How? Solution. So Tc, your function is Tc is equals to 9c by 5 plus 32. Therefore, so T of 0 is quite simple, is going to be 9 times 0 by 5 plus 32, which is 32. So T of 0 is 32. So 0 degree Celsius temperature is same as saying 32 degree Fahrenheit temperature. Clear? Now for second. So T28 is 9 times 28 by 5 plus 32 is 412 by 5. For T minus 10, it is 9 times minus 10 by 5 plus 32, which is 9 times minus 2 plus 32, which is just 40. So minus 10 degree Celsius temperature is same as 14 degree Fahrenheit temperature. Now for fourth, it is given that the output value is 212, meaning Tc is 212. And we know that Tc is simply what? 9c plus 5 plus 32. And now we are having an equation. Just solve it. You will get what? 9c by 5 is equals to 180, which gives me 9c is equals to 180 times 5, which is c is going to be 100. So for 100 degree Celsius temperature, you will get your 212 degree Fahrenheit temperature. Clear? Now this question, just find out the range of the following functions. So for first, fx is 2 minus 3x, where x belongs to set of reals and x must be positive real numbers. For second, fx is equals to x square plus 2, where x is your real number. For third, fx is equals to x, where x is your real number. So quite simple problem. Already given the domain. Yes, domain is already been provided to you. Just find out the range. You will have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple problem. Three functions are given to us with their domains. We just have to find out the range, meaning from where to where the output will be lying. So for first, the range set is going to be open interval minus infinity to 2. For second, the interval closed at 2 open at infinity, and for third, the range will be the complete reals. So solution. How we are getting our range? Quite simple. Fx is equals to 2 minus 3x already given to us, and we are provided that x must be real and positive real number. Now the value of fx for various values of real, positive real can be written in the tabular form. So we are just observing some pattern. So for real number which is very near to 0 comparative to others, so 0.01 the output is going to be 1.97. For 0.1 the output is 1.7. For input 0.9 the output is minus 0.7. For input 1 the output is minus 1, and so on. So what you are observing is that the range of f is the set of all real numbers less than what? Less than 2. Yes, 2 is excluded, 2 is not included. Why? Because the output is equals to 2 when x is 0, but we are taking values x greater than 0. So we are getting our range set every real number less than 2. So in interval form this will be open interval minus infinity to 2. Clear? So solution. So here x is positive, 3x is positive, 2 minus 3x is less than 2, and fx is less than 2. So another way to find out the range is using this inequality. Clear? So one way is this. Now for second, so fx is equals to x square plus 2. X is your real number. So for values of fx, for various values of real numbers x can be written in the tabular form. So we are trying to just observe outputs and then answer the range. So it can be clearly observed that the range of f is the set of all real numbers greater than 2. So you are getting your range as interval closed at 2 open at infinity. Clear? For third, so for second the alternate solution. So x, any real number, accordingly x square is greater than equals to 0, imply x square plus 2 is greater than equals to 0 plus 2, x square plus 2 is greater than equals to 2, and fx is greater than equals to 2, and fx is your what? The output values. So what you are getting is that the output is going to be either equals to 2 or greater than 2. So the range set is closed at 2 open at infinity. Now for third, as given fx is equals to x, x is your real number, it is clear that the range of f is the same as the domain or the values of x. In this case, which is the complete set R reals. Clear? So this is it. Thank you.